right. So hi everyone. We are doing another coding game puzzle today. Actually, it's part 2 of Lumen, which you're seeing on screen here. So just a quick recap of the puzzle itself. Basically, the idea is like you're in a square room represented by these here. You're being passed a series of strings, lines, and each square is an area in the room, and there's a candle or more. There's one or more candles in the room, which are giving off lights at a certain strength, represented by this parameter here. And here is the size of the room, and it's a square room, so 5 by 5 in this case. And basically your task is to determine how many dark spots, dark areas there are in the room for you to hide in. So in this case here, there's one candle giving off 3 powers of light, and the power of light reduces by 1 for each um, spot away from the candle. So you see here that so the candle itself is 3, then next to the candle it's 2, and then after that it's 1, and then 0. So in this case, there are 9 empty or dark spots. That's your task. That's the output it's looking for. See, line 1, the number of places with 0 light. So a simple number, basically. So I was not that far along in this one. Let's bring up the code. So what's happening here? Well, first, we're getting the room size number. We're getting the light strength. Then here, what I'm doing is I am, I'm basically getting each line in a loop, each line, each string that represents a line. Okay, and now what do I need to do that? Oh yeah, my idea was to basically take this input and map it to this here. And then it's an easy step to just count how many zeros you have in there. And oh yeah, and this, oh, I remember now. So I ran into a problem where I hadn't realized, but they are separated by spaces. Each spot in the room is separated by spaces. So I figured, and that's why I have this here to do, remove spaces from line. So that's where I was at. So let's do that so that we have a nice, tight, compact array without any spaces in it. Well, actually, our array is just an array of lines, basically. So I want the strings in there to have no spaces. So I can just use, instead of making an actual 2D array, so I can just use the string, what's it called, that car at method, which allows you to just, give an index and it'll tell you which character is in the string at which index, basically like an array. So why switch the string to an array when it's got a lot of the array's properties and methods. Not all of them, though, mind you, but I think it has what we need. Okay, so how do we push a string that has no white space in it? I think I had looked into replace. Yeah. So replaces text in a string using a regular expression or search string. String containing the text to replace for every. Oh yeah, I remember. I had a problem trying to do this. For some reason, it only replaced the first space. So I'm looking for a space, and I want to replace it with no space. So seems easy enough, right? But let's run this. If I remember correctly, and I'm printing the room. Yeah, okay. So let's run. No, you hide. this is what we want. Oh, I just have to turn on my, what is it again? Run npm dev. No, that's not it. Oh yeah, it is, but I'm just not in this in the right directory. I should be in the Lumen directory. Then run npm dev. Nope. npm run dev. We'll get it. Okay, there we go. Okay, so it's automatically building as I'm doing changes to the file, building my TypeScript into this JavaScript file here, which coding game is picking up. Right? Yeah, see, it has my replace here. Good. So let's see what happens here. Okay, so this is the problem we had yesterday. It's only it's only catching the first space here and removing it. The other ones it isn't. So I suspect there is something that I don't get with the replace method. Do we have, oh, there you go. Replace method returns a new string with some or all matches of a pattern replaced by a replacement. The pattern can be a string, yeah, that's what we're using, or a regular expression. And the replacement can be a string or a function to be called for each match. If a pattern is a string, only, there you go. If a pattern is a string, only the first occurrence will be replaced. So we need to get a regular expression. Whoop. Nope. 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 Yes. Regular expression. Let's see. I think spaces are S. And if we want it to catch all spaces, we need that global flag here. Let's give that a try. Not a regular expression whiz, but yeah. All right. Okay, so that was our problem. And now it's no longer a problem. It is solved. So we've got our array of lines, which are strings. What did we want to do? What's our algorithm going to be like? Oh yeah. So I need to find the position of all the candles and map this. That's going to be our first step, right? I'm going to first go through the array, look at the positions of our candles, and then map them to that new array. Does that make sense? Yeah, and for each x, I should just throw a 0 in there. That's what I'm going to do. So that's going to map our array from this to not quite this yet, but at least we'll have the 3 and everything else is 0. Then it's a matter of going through the array and finding our 3s, then shoving 2s all around it, and then going back and finding our 2s and then shoving 1s. Yep. So that looks like a recursive kind of function. We'll look into that when we get there. Okay. So this is done. Now, map room for, what am I doing? I'm making a mapped room, which is a map of the room array for each okay, I'm iterating through the row. So what I need to do here is if row dot car at j. I guess I decided to use j here because just this is essentially a loop, right? Oh, I'm using I here for the index. Okay. All right. So that's why. So if It happens to be a candle. We want to return, oh no, right, because I'm actually, I have to return map. Takes a callback function that accepts up to 3 arguments, calls, get back here, you. Function that takes the map method calls the callback function one time for each element in the array. Yeah, but it needs to return a line, a string. So let's call this mapped row. And for now it's an empty string. So now we're going through each character. If you find a character that's a C, I want you to concatenate our mapped row. Is that gonna, yeah, that's gonna work, because what should we throw in there? Oh, it needs to be the light strength. Light strength, right? Light strength, which is an integer, but, right, it's a number. But JavaScript should make that into a string. Or do we want them to be numbers? Well, we don't really care. It'll work either way. And if it isn't, then it's an X. That's our only two options. And in that case, you're going to add 0 for now anyways. And then once you're done doing all of that, you're going to return our mapped row. Okay, so, all right, it's typing this properly. It's saying it's going to be a mapped, an array of strings. So let's see what we get when we do that. Mapped room. I gotta stop doing this with TypeScript. Okay. Completely empty strings. Oh, I think I had a problem with that, didn't I? J equals 0 if j is smaller than room size, j++. I'm really confused about that. It's not picking up this thing here. I think I had that problem yesterday as well. Oh, it's actually not doing anything with this either. All right, I don't know if you see this. I don't get that. That is so weird. I wonder if maybe what if I extracted this to some function? See if it would deal with this differently. Just for kicks. Let's call it look for candles. Let's call that. Yeah, whatever. Let's just trying something out here. Let's see if it'll. No, same thing. It just doesn't like it. That is so weird. That is so very weird. Okay. So I'm using rollup to bundle my TypeScript code. So it transpiles it, and well, technically TypeScript's doing that, the TypeScript transpiler. But anyways, so Rollup does that and bundles the code, and I have it bundling it in 3 different formats. One is CommonJS, which is the one that I'm using with code in game, and you can see the output here. Clearly, there's something wrong. I don't know if it's something I'm doing, if it's a bug, whatever. But let's take a look at the ES module version. Same thing. Same thing. UMD. Same thing. It's not picking up my... What am I doing? I can't believe it's... Okay, you know what? Let's try something. Let's try something here. It's a quick and dirty way of... See, this is pretty simple, right? Actually, just that. Let's see what TypeScript's going to do with this. Yeah, of course, I'm missing all kinds of things. Oh! No, it's taking it, but let's see if I give it, just to make sure everything works right. Room underscore size equals 5. Make that a const. Okay, what are we missing here? Row. So it's just row is a string. Okay. Map pro. Is also string. And then light strength. Yep. So that's weird. TypeScript transpiler seems to be transpiling it properly for now. Right? It's not missing anything. It's taking our map row light strength. That's so odd. Why, oh why doesn't it work with... Let's take a look here. JSON. Do we have any special settings in here? What's it doing here? So Rollup can find external common JS modules. So Rollup can convert external common JS modules to an ES module. So Rollup can convert TypeScript to JavaScript. So that's the plugin it's using to do the bundling. What if we were to try? Let's try something here. Yep, let's stop that. Let's try TSC. So we're basically saying we want to run the transpiler on our main.ts. And it should just output the TypeScript right there, the JavaScript here. And it's dealing with it properly. So why? Why? There's got to be a problem with the... There's a bug with the TypeScript plugin, I'm guessing. Let's see. If I was to forget about these here. Common JS for Node and ES module for button. No, doesn't make a difference. That's just for the UMD. I'm stumped. I'm going to have to open a bug, an issue or something on the rollup library. But for now, we want to continue with our exercise, and I don't think I'm going to be, the reason I'm using rollup is so that I can use with the coding game if I wanted to, external libraries, or if I wanted to start using, split my code in two different files, but I don't think I'll need to for this exercise. So here's what I'm going to do so that we can just keep going for now. I'm going to switch the file that we're using. Can I do that here? I'll just do off, on, change local file, go get our this file here, upload from local file to coding game. That worked. That's not. There we go. And now it's got our. So if I try that again, it doesn't make a difference. Well, that's funny. That is funny. Was it somehow picking up the fact that I must have something wrong in my code? Same thing here. You know what? I'm starting to think there's something wrong in my code. And rollup for some reason is smart enough to pick it up or something. I don't know. It's really odd. Okay, so we're back to using our built file from rollup. We're going to try to figure this out. So here's what we're going to do. Let's take a look at our rows first. Going to debug with the console. Error. And just to make sure we're getting our rows inside our loop here properly. Let's map that out. Or no, let's just leave it. Oh, I don't think it picked up the change. Oh, right, because I didn't build it. Okay, let's see if it picked up the change. Yep, my console's here. Okay, so obviously it's getting the information it's supposed to get. Wait a minute. How am I? Oh, right, it's getting it because I anyways, I just wanted to make sure it was in there, so that's fine. No biggie. So now let's see what we get when we do this. Okay. Wow. Weird. Very weird. I'm looking for a capital C. There's obviously one. It is a capital C, right? Yeah, it is. Okay, let's try this. See if the if statement's working. console.log dot error. Picked up. Picked up. C. Yeah. Okay. So the conditional statement's working. So it is obviously something here. I don't understand what our problem is. Why can't I just simply add to the array, to the string? Did I close down the... I think I did. So it's really not liking this string thing. So then I guess I could just make it an array. So this is going to be an array of arrays, and might as well make it numbers, because that's what's going to be in there. Map row, variable map row implicitly as type any. Yeah, we don't want that. Let's tell it that we want an array of number. Now here, we're going to take mapped row dot push, and you're going to push the light strength. And if you're not a candle, then we just want a 0. So mapped row dot push. Yes, dot push 0. All right, let's see what we get with that then. Okay. That's what we want. Except, what? Wait a minute. 1, 2, 3, 4, 5. We've got 6 here. What is going on? Where did the 6th one come from? Oh, yeah. Silly me. Because I didn't make this an else statement, so it's doing both. Fun. There. That should fix our problem. Yes. All right. There we go. So. What do we do with this? Well, now we got to make sure that we get 2s here. And then that we get our 1s here. So in essence, the algorithm is find number L, right? L, which is our light strength. And then for each adjacent position, throw in L minus 1. All right, and then we repeat the process. We look in the array for each L minus 1 and put in each adjacent places L minus 1 minus 1. Except if there's already something bigger than L minus 1 minus 1. Right, because we don't want to undo the 2s that we just put in. So I'm pretty sure we can do this recursively instead of having some ugly kind of loop. So we already have this. This is, okay, with that we end up with our mapped room. Once we have our mapped room, let's make this a recursive function. Well, let's figure out the algorithm first. So first thing we want to do is look for the number, look for each, so we need to iterate, right? We need to iterate. We don't have a choice. For let row in, oh no, I'm going to need more info than that. Probably just going to use the maptroom.forEach, which gives me access to the value in the index. That's all I need, I think. So the value is the row. The index is the index. Do this like that. Now we're looking for, we are looking for, we're looking for our light strength, right? That's the first thing we're looking for. So if, I'm wondering if I even need to do that, if I couldn't get that done in here. The problem is that all we have is our X's and C's. So that wouldn't be, no, it would have to be two different algorithms. With this one, I can do it recursively. But I couldn't do that if I started off with C's and X's. Well, I could with like a bunch of if statements and, okay. So, if row square I. Oh no, what am I saying? It's, I still need to have my inner loop here. Same as this, basically. Similar, anyways. We'll see if it's, we can refactor later and maybe there's a way to reduce duplication. So row, and this time I'm using, it's an array, it's not the string, so J is equal to light strength. Light strength. What do we do? Let's forget about that for now, because that's really the only thing we're interested. Oh, and it's not maptro, it's row. And it's not push. What am I doing? It's none of these things. Okay. Oh, now what? What have I done? I'm missing this here. Okay. All right. So what do we want to do? We want to populate each adjacent spot with light strength -1. That's what we want to do. So what we need to do is I'm wondering if that's gonna, no, I don't think it's gonna screw up the loop, right? Because we're looking for light strength, and if we add light strength -2 to other positions, that's okay, yeah. It's not a problem. So how do we do that? Well, we've got our position, which is ij, right? That's our 2D position. So we need to make sure that we get each case. We've got, how many positions is that? 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Got 8 positions because we have to do diagonals too, I think. Yeah. All right. Let's do this very the dumb way first. We'll figure it out. So const, let's use cardinal directions like north, south, and all that stuff. So const, let's start with northwest. equals I is our row, j, no, I is our row, so I would be our x, and j is our, or I is our y, and j is our x, right? Right. So NW equals, we'll just make it a simple, can we make it just a array like that, or do we go through the trouble of making it, nah, let's just make it a, although I don't like that, it gets confusing when you do that, so let's just do y and x. All right, we could do that. Oh, here. Let's make ourselves a little position class. Takes a constructor. Constructor is going to get a private. No, we don't want a private. Let's just make it public for now. We want to be able to set it and get it easily. So our x and public y. Let's type them. They're going to be numbers. Wait. Actually, I don't need to do that. That's a nice TypeScript feature. If anyone's watching, no, but if you're watching the recording because you're weird, that's a nice TypeScript feature in the constructor. If you make your parameter either public or private right in the constructor, TypeScript will automatically assign the parameter to a field, right, or a property on the instance. You don't have to go and do put it here, put x here, and x is number, and then go through this, and then this dot x is equal to x. You don't have to do none of that stuff, which you have to do in JavaScript and other languages. This is kind of a shortcut. It's pretty cool. It's slick and it's easy to understand. So this is all that we need for our purposes. So where is Northwest? Northwest is a new position, and it's going to be at I is our, what did I say? I is our, it's the opposite, yeah. So J is our X, I is our Y. Okay. So if I'm standing here and I want to get northwest, let's start with north, like a regular people. Let's make it a const. Okay. So if I'm standing here and I want north, I just need to go up 1 on the Y. So I minus, right, because we're -1. Okay. Now what happens if we are out of bounds? Ugh, that is so annoying. Gonna have to check for that. Should I check for it now? Actually, do I even need to do that? I can just simply because what I need to do is mutate this stuff right there. So do I even need to store the position? Well, I do, but in a I should have a set of position. Oh, I know what I'm going to do. Yay. I'm going to make an enum. Would that work? No, that wouldn't work. Okay, so basically, okay, this is what would be cool. Let's just scrap all of that. If I could just say, give me your position. So if I have a function, which we're going to call, bar, and comma, foo then. Just don't give me, okay. Let's go in foo, pass in my x, which is the j, pass in my y, which is the I, and then you just return the position of what? You just give me an array of all the positions that need to be changed. Yes, that would be nice. And then I can change them in there, or should I just change them somewhere else? Yeah. Okay, I'm getting ahead of myself here. Just solve the problem and we'll refactor afterwards. But it would be cool if I could just do what if it's a map? I have a map, north, then you'd have the function. Or it could simply be an object. Yeah, we're going to make this an object. So const some object. Naming is too hard. I'm delaying that decision. And it's going to be an object of all the cardinal. What do you call those again? All the north, south, orientation, whatever. And it's going to be a function. Right, so, and it's going to take your x, it's going to take your, which is a number, x is expecting a number, y expecting a number, and it's going to say, yep, so your north should be, what are we returning? What are we returning? An array? I don't like returning arrays. We'll return, oh, should have kept our little position friend. So class position. There we go. Constructor takes an x number. Let's make it a public x number and a public y type number. Okay. And then you're going to return a new position made up of x and y minus 1. And northeast. Northeast is going to be up 1 plus here, x plus 1. Okay, then east. Uh, oh. Now, I didn't deal with the case where we're out of bounds, but that would be the right place to do that, I would think. Maybe not. So what happens if I'm out of bounds? I obviously can't. At some point, I'm going to have to check for out of bounds. So let's delay that decision to later. Just copy this. So if we're to the east, then we're just keeping this like that. Southeast, we are still doing that, and now we're adding one here. And south, we're doing nothing with x. But we are adding to y. And then southwest. Southwest, we are removing 1 from x and still adding 1 to y. 1 minus 1, y. I think that's right. And west. West, we are this stays like this. So right, west and east, the y-axis should move. And north and south, the x-axis should move. So that's right. We got it right so far. This one is northwest. Northwest, we are removing 1, and we are removing 1 here too. So basically diagonals, I should be doing something to both. Yes, 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 yes. And the other cases were fine, so I think we're good with that. Now, time for a sip of water. Okay. So now it should be relatively easy if we do find a position where we have our light strength, number 3 for the test case we're working on right now. So when we get to this, now I need for each of these pass in this, get my position. And then basically use that to put a light strength -1 in all of these positions. How do I want to iterate over this? It would probably be better then to make it an array, because I don't need to actually call them individually. So you know what? Let's do that. Const. Adjacent. What are we going to adjacent spots. Functions. Yeah, it'll do for now. This one here. And do I care about these before I go ahead and, I don't think I do. Boop, boop. Oh, it doesn't work. Let's see. Does that work? No. Okay. I think TypeScript doesn't matter. Okay. All right, and in here, what do? We go adjacent spots functions dot for each. And that's our function. I don't think we care about anything else. Do we care about the index? We don't. In this case, we don't. So we can just go like that. And what do? We call our function. Now it's more complicated than that. So find adjacent position spot. That's what we're find adjacent. We'll call this the same word. Find adjacent spots functions. Find adjacent spot functions. Find adjacent spot functions dot for each. Find adjacent spot. So find adjacent spot, please. And where x is going to be the j and our y is going to be the I, which should output a position. Yes. Now what do we do with that position? That is that is the question. So spot. Then with that spot, we have two. Spot should be a position, right? Okay, yeah. So we're basically saying, take the mapped room, which now is a 2, yeah, it's a 2D array. And this will be, that's our Y. So take our spot.y and then pull up our spot.x and then shove in there light strength -1. Yes, 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 that's what we're doing. All right. Now, of course, we're only doing one pass of this, so we're only going to get our 2's. If I did this right. Let's find out. We did. See how long it took, though, to run this thing? Well, maybe if I run it again. Okay, it was pretty quick. Just because it was the first time. All right, so we got confirmation that the algorithm works. Now all we have to do is do it recursively to map the entire room that way. So this is basically what we could make into a recursive function. Is that right? Do we need to do the entire thing, or do we need to, or could we do just this? What are we doing here? We're going through each line. And then on each line, we go through each position. And when we find a position that is the light strength, then we look, then we get all of our adjacent positions, and we shove 2 in this case. Yeah, so that is what needs to be done recursively. And how do we do that? We make it a function. Start with, how do we know that we're done doing this? We know that we're done doing this when we are down to 0 in terms of this variable here that we're, so we need to pass in that variable. So we're going to call that variable fittingly light strength. Light strength is going to be a number. And on each recursion, that number will be decremented. What am I going to call this? Function map room. But I can't. Okay. So technically, if I take this, put it in there, and then just change this for that here. Missing. Oh, I always do that. Strength. Gotta learn to spell this thing properly. Strength. Did I spell it right here? Yep, I think. Okay. So technically now, if I just ran this, passing in our light strength, I should get the same output. Is that property 0 of undefined? Yeah, okay. So we're going to have to deal with that. See, that's an out of bound thing, but for now, we know that it works. Okay. Let's just get this. So how do we recurse this then? First, we know that we're done if light strength is equal to 0, which I think we can just do this because 0 returns false. Then we return. Simple as that. But if it isn't, we do this. And when we're done doing that, we call ourselves. What am I doing? We call map room again. And this time we're doing light strength -1, please. Thank you. Let's see what that does. What are we getting? Oh yeah, then we're running into the out of bounds problem. Let's fix that. So if we're out of bounds, we don't want to do anything. We don't want to try to map this. Wait a minute, what happens when you try to map to a negative index? You try to push something to a negative index. What's the error I'm getting? Type error. Cannot set properties 0 of undefined. You're getting it. You're getting undefined. Okay. Because it hasn't been set in the area. Yeah, okay. So what's the best way to handle this? We could simply do a check in here. That's probably the easiest way to do this for now. Let's do it. If spot dot y. So again, we're checking for if it's negative. Would a negative number return falsy? let's make a quick, here. Where's my, okay, there it is. Just some fun in the console. So if I say, 0 equals false, it's saying false. Then that's probably not the right way to check this. If 0 is equal, just if 0, and return, if 0, return, there's no return, just console log. True. Okay. I'm not being smart enough to do this properly, so let's go with false, false. A false value is a value that is considered false when encountered in a Boolean context, which is, that's exactly what we're. Those are false values in JavaScript, which are coarse to false in Boolean context and thus bypass the if block. False, of course, 0, yeah. Truthy. 42, yeah, okay. That's all we wanted to know, so. So I can't do this. So if spot.y is smaller than 0, or actually, let's do it the other way, bigger or equal to 0, and which is this one here, and spot.x is also or bigger than 0. And then go ahead and do this. Otherwise, don't do anything. See if that fixes our problem. It does. Oh, but it creates another one. How did we end up with zeros all over the place here? I know. Oh no, I don't know. If rho j equals light strength is here. What did we end up with? Whoa, that's messed up. Not the intended result. Oh, I'm inside. Am I inside the? No, I'm not. Should I be? No, I shouldn't. So I'm running through the array, the entire array. Each time I find something that is equal to light strength, I find the adjacent spots. Say y. Spot on y is bigger than 0, and spot on f, then I light strength minus 1. Oh, right. I'm running to the I need another conditional. Oh, conditionals upon conditionals. And so if spot y, and also if spot the if mapped room, well, actually this here. So let's not evaluate twice. We'll call this target spot. Or maybe just adjacent spot. Yep. Adjacent spot. Adjacent. 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 Did I spell it? Yep. Adjacent spot equals this thing here. And then if adjacent spot is smaller than light strength. Only if it's smaller than light strength are we to this shouldn't be -1, this should be light strength. All right, so we're looking for light strength. So we're starting off with 3. So once we've found 3, no, it's -1. It was right. So let's see. Aha! I do believe we got it. We have the output that we want with our nice little recursive function. Now what we have left to do is to just parse this, parse this mapped room. Now there might be, oh, I should look, I think there is. There are new array functions now, I think, that flatten multiple, not multiple, what do you call those? Not multi-level, but you know what I mean. Arrays within arrays. I don't see it here in my list, but that might just be because I'm not using ESNext, right? But first let me check to see if I can MDN array. Flat, yes. Method creates a new array with all subarray elements concatenated into it recursively up to the specified depth. So we could simply do that and look for all zeros and we're in business. Or we could just do a reduce. Let's see if we could just do a reduce. Reduce. So it's going to go through each line. Each line is an array of numbers. So we're going to call this row. So previous has to be, we'll call that count. And we'll call this row. This needs to be inside a bracket. Like that. Do this, do that. Okay, and we tell it that we're starting up with 0. Now we need to count the amount of rooms that have 0. So row, if row is equal, no. I need another, man, loops and loops and loops and loops. For, but this time I'll just use this, for spot in row of row of row. So spot of row. Okay. Spot dot. It's a number. Yep, we're right. So if spot equals 0, then return count plus 1. If it isn't, just return count. Okay, what seems to be the matter here? Argument of count number or undefined. It's not assignable to parameters of type number undefined. Why would you return undefined? In what situation would you return undefined? The only thing I'm doing here is going through count is a number. Count is a number. I'm only returning numbers. Where do you get undefined from? Mm-hmm. Maybe if I do this. Oh. Right. Ugh. Okay. Well, I can probably mutate that the way I'm doing it right now. But I don't want to return it then. All I want to do is count plus 1. Then here, don't do anything. Then just return count. Is that going to work? We're about to find out. Const answer. Answer. He's working hard. He's not working. Let's try it again. I'm getting a 0, so obviously not working. Accumulator. Dum, 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 dum. Count equals 0. And count plus 1. Return count. Return accumulator plus count. How's that? Cannot read property 1 of undefined. I'm going to have to look into that later, but why isn't this working? I don't know. So, and I don't feel like debugging this. Map room not flat. There you go. Oh. Let's change that here to probably ES next. ES next. Or is that going to work? Don't need you anymore. Q. Yeah, there's our flat. Returns a new array with all subarray elements concatenated into it recursively up to the specified depth. And if I'm not passing in a depth, it's probably just going one level, which is all that we need. And so then once we have that, we can now we can do a reduce, and it'll be a little easier to do. So the value, the previous value is going to be the count. Let's get our count and light strength. Light strength. And then once we're done with that, we can simply, actually, yep. If light strength is bigger, no, is equal to 0, that's what we're looking for, then return the count plus 1. Otherwise, just return the count. What? Mapped room dot flat is not a function. Oh, it doesn't have it in that version of Node. No, unfortunately. Right, so no yes next. Yes 6 maybe, but then it doesn't have the flat. Ugh. So then, let's do it ourselves. Mapped room dot map. Take our array, so which we're going to call a row. That's all we need. And you're going to return no, that doesn't work. We can't do it that way. What's an easy way to unpack an array? Okay, I'm getting annoyed with this. This shouldn't be so complicated. Let's just use for loop and let count or answer. Let answer. There you go. Equals 0 for each row, const row of mapped room if row I gotta go and do another one. Yeah, so let's do it. For const spot of row not sport, spot. If row spot is equal to 0, then answer +1. Oh, that's what I was doing wrong. I'm so dumb. Oh, can't believe this. Cannot believe this. Ugh. All because I didn't want to do plus plus. And you'll see if you haven't figured it out yet what I was doing wrong. Just going to get back to... Oh, I still can't use the map though, but I can use the reduce I had first. So let's see if I can go back. Yay, okay. So if spot equals 0, count plus equals 1. Yeah, I know. Oh, but still the, crap. Yeah, that's not going to work. But I think, oh, it does work. Yay. How come? Reduce for this, count plus, oh yeah, why wouldn't it? Why wouldn't it work? All it needed was a return here. And okay. So let's see if this one's going to work. It doesn't. Cannot read property 1 of undefined at answer JS blah 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 blah. What's our test case here? Five, 3. They're on each corner. Interesting. Let's grab the whole thing. which should give us 3, 3, 3, 3, and then 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and then 1, 1, 1, 1, 1. So basically, nowhere safe. Let's take a look at our mapped room. No, still good. Where? Wait. Oh yeah, okay. Cannot read property 1 of undefined. Answer JS null on line 49. Line 49 of the JS. JSON spot equals mapped spot. How is that even possible? That I get to that point if okay. So let's first make sure that we've got our room properly. Oh, it just won't run. It won't run anything. So just don't map anything yet. Forget about all of that. Actually, let's do that. Okay. So this works. This works as well. So we get the room properly. Let's see what happens when we try. What is that thing? That's going to be hard to debug. I should probably console.log error, error and get our mapped room at this point. I don't know if this will work, but okay, we're getting it. So you see it shoves the 3s in there properly. Threes and 2s actually. How come? Okay, we're basically seeing where it fails here. 3 twos, twos are here, then boom, when it gets to that here, it doesn't work. It fails with. Cannot read property 1. So you'll be looking for, are you looking for? Let's see what the, oh, that's not what I wanted to do. This is what I wanted to do. So it's looking for position x1, y5. And what's our array looking like? Why on earth would it be looking for that? Mm-hmm. Oh, of course. I'm only checking for what's out of bound in the negative. I'm not checking for what's out of bound in the positive. Oh, okay. So if spot dot y is smaller than 0, that's actually worthless. Now that I'm thinking about it, because our position, our starting, let's see, is it relative to or is it absolute now? I'm getting confused. We're passing in this, oh, no, it's absolute, okay. So this is good, but we also need to check that spot dot y is smaller than room size. Let's not forget our end here. And spot dot x is also smaller than room size. Pass in our answer. See what happens. Don't get rid of that console log. I think I'm pretty sure we've just found the problem. So this is working, and this is working. Working. All right, I think we got it. Boom, 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 boom. Solved. Thank you. But the code looks like a crap. So We got about 20 minutes left. Let's refactor. So what could we do? What could we do? What could we do? Got a bunch of if statements and loops within loops, and I don't know if it can be helped or not, but we're about to find out. So that we don't have much of a choice. We need to read and populate our room. Or could we do this work right in there? Probably can. We probably can. Right? Right. If we were to what are we doing in here? We're mapping this to, oh, you know what? Before we do anything, let's push, let's commit this. So add solution to, what's it called? Lumen, to Lumen puzzle. Now let's break stuff. Okay. For each I, we can just replace this. I'm pretty sure we can just replace this. Just throw it right in there. Save ourselves a loop. Right? Let mapped row. So we're basically turning the row into an array of number. Which we're going to put right here. Um, let's see. First thing we need to do is clean up our line. So as we're replacing this, we're doing a little replace thing, which was S, yeah. And then we're replacing it with no space, so that takes care of that. So we've got our line, which is now a string. Without spaces, and now we iterate over that line, and then for each line, character at j If it's equals to C, our mapped row gets light strength, else our mapped row gets nothing. Then we push this mapped row to room dot push. Okay. Oops. Doesn't seem to like that. Of course it doesn't, because room is now supposed to be a 2D array. There you go. Let's run our tests, make sure we didn't break anything. Ooh, looks like we did. Mapped room is not defined. Yeah, okay. Where are you, mapped room? You're now room. Ooh, I was using this mapped room thing all over the place. Doing a lot of mutations here, but it's not too hard to think about. So. Okay, we're good. Rid of this. What's next? We got a map room function. Get our answers here. Just don't need this anymore. All this could probably be called something, right? Make it more understandable what is going on. Oh, it'd be really nice if I could just have this one mapping function instead of having to do this first step. I could probably do it just in one go. I just need some if statements to deal with those cases. I'm really tempted to try. Okay, what if we were to try it? What if we were going to say, you know what? I just want to deal with all of this as it comes in. Could we do it? Could we do it? We're getting strings line by line. So the first pass is not going to be a problem. I can just switch the C's to 3's and the other ones to 0's, which is what I'm doing anyways. Nah, this doesn't make sense. So I gotta, yeah. I think because see if I could have like if this is the first go at this, then parse all of that, and then afterwards. But I mean, what's the point of that? It just gets unwieldy and big, and your function ends up doing a bunch of stuff. So we're just going to leave it like that. Yep. I mean, I know we could clean this up, but honestly, I think I'm just going to leave it like that for now. Maybe revisit this later. Pretty satisfied with our solve. I find this is a pretty neat way to do it. Yeah. Okay, so I'm going to leave it like that for now. And submit my, oh, gotta run the tests again because I did a bit of refactoring. There we go. Submit. Computing score. Congrats, you've reached level 12. Woo, it's exciting stuff. I will keep coding. One does not simply level up on coding game. Oh wait, I totally did. That's cute. Okay. All right, folks, so that's it for today. Thanks for watching. I'll see you. So this is Friday. I'm probably going to stream until next Monday, 9 a.m. Eastern Daylight Savings Time. See you then.